Hello guys, today my topic is on draft proposals. I proposed almost 4 topics here. I am Saurabh Barua presenting the research proposal topic. So my first topic is on physics informed resilient drone brace framework. It also includes eco-friendly and all these join together to build a adaptive traffic control, and I named this D-Quartz Plus. And this topic will cover traffic data collection using drone video footage, then Q estimation using physics informed neural network. I will consider failure mode of data collection, also include emission. I may use VT micro and moves model. Then I will take adaptive signal control using deep reinforcement learning and proximal policy optimization. And lastly, I will deploy SAP, that is explainable AI type model, to explain the traffic signal control system. This is the topic 1. In the topic 2, I will use a hybrid physics informed model using generative AI, and it will impute traffic data and also build a traffic state estimation for signalized intersection. Obviously, in this case, I also use sparse drone trajectory. So this topic 2 will cover traffic state estimation using drone, sparse and missing trajectory data, physics informed with generative adversarial network to estimate flow speed density, then using Bayesian PINN for uncertainty measurement. In the topic 2, I will build another drone based model. It will also use prop vehicle data, and it is uncertainty aware, and it explains deep fusion framework for high resolution trajectory data reconstruction, and also it will predict travel time. So this topic 3 will cover drone and probe data trajectory reconstruction using graph attention network, then fuse trajectory for predicting travel time. In this case, I can use a transformer with explainable AI, and lastly, uncertainty will be measured or modeled using Bayesian interference. In the topic 4, I will try to develop a multimodal drone safety net and use explainable graph-based deep learning framework, predict surrogate safety assessment. I will consider heterogeneous vehicle dynamics. So this topic 4, I will collect data using drone, observe multimodal vehicle dynamics, then compute surrogate safety measures and predict trajectories for SSM, that is surrogate safety measures. I will use GNN, graph neural network, and compute using LSTM and logit models. These are the 4 topics I will cover. So let's talk about the topic 1, that is DQ ART Plus. It will have physics informed resilient drone based framework for eco-friendly adaptive traffic signal control. So I have several parts to join together to build this system. So motivation of this study, that is topic 1, is traffic management framework development utilizing drone. I will use artificial intelligence to urban intersection, and most important part is I will cover to estimate accurate queue length, then integrate physics informed NNN neural network and deep reinforcement learning. It will help to reduce emission and congestion, and focus is to build a resilient system, resilient by means of that it function during even during sensor failure or partial data loss. In the last part, I will incorporate explainable AI to AI to explain the complex scenario of automated decision and make it understandable and trustworthy. And this project target is to develop a sustainable data-driven solution for adaptive traffic signal control. These are the motivation of my study. And here is some literature review. We can see that I have almost 8 literature review. Firstly, the paper 1 that is on real-time traffic state estimation, and it will cover adaptive Kalman filtering, and I mentioned the research gap of this paper and how I can my proposed study can address this gap. I mentioned it here. In the second paper, we can see that based on the microscopic evaluation of signalized intersection, here also the drone data was collected, and they faces challenges of high computational complexity. I will address through my research objective 1 and methodology about this paper. In the third one, we can see that the Zhang et al., the multi-objective deep reinforcement learning were used for the safety, efficiency, and decarbonization. In the next one, they identify the Q profile for unsupervised clustering. This time also use drone data. The gap I want to address here to evaluate a framework which is resilient and have some scarcity using synthetic data, approximately 50 to 100% coverage. In the next, we can see that the paper Agant is based on the deep reinforcement learning. It develops Ecolite to reward carbon dioxide reduction. Then next paper is fuel economic traffic signal light development. It also integrate eco-driving. The seventh one, that is Rizzo et al., it explained the reinforcement learning for traffic signal system, and it used SAP, that is explainable AI system. And I want to include eco-mobility trade-off and also address overfitting gap, which is the research gap of this paper. In the 8th, we can see that it developed a large-scale monitoring data set from drone swarm, and they use multimodal trajectory data. The problem that is not addressed in this paper is on the isolated intersection or corridor, rather than it's not focuses on the isolated intersection or corridor, rather than large scale network was used here. So I can specifically concentrate on a small network, which can give a different type of result. This paper used swarm architecture, drone swarm architecture, and for multimodal trajectory data. And if we summarize the research gap of the paper, we can see 4 types of gap. One is physics deep reinforcement learning gap. This type of network is not used for traffic state prediction, which is adapted to LWR model, that is Lighthill, Whittam, and Richardson model. And resilience gap is not discussed. While highlighting the weakness of low coverage data, my proposed paper will discuss with the resilience stress and generative adversarial neural network in imputation related missing data. The next one is explainability gap. My proposed paper will use SAP to audit the competing objectives regarding the throughput and emission, which is important gap is not addressed in the reviewed paper. And the empirical grounding gap, that the research my research will address the resilience of simulation only emission data. I want to embed or combine VT micro and MOVES database along with the drone trajectory data. So these are the 8 reference paper and corresponding link I am providing here. So what are the research novelty of this paper? In this paper, I have 4 research novelty. One is physics DRL integration. This is the first framework to unified physics informed neural network for Q estimation and resilience benchmarking. I try to figure out the topic, try to explain the failure modes like occultation, frame drops, reduced coverage, empirical emission grounding. I want to include PT, macro, and moves type model for emission point of view, and this will including the eco-friendly reward function. Dual layer explainability, I'll use SAP and attention weight visualization to audit the mobility versus emission contribution for signal decision and traffic signal control system. So these are the 4 novelty of my study. If we look at the methodology concept, firstly, that is data, step 1, that is data layer, collect high resolution trajectory from drone using data from sky. In a step 2, resilience stress test will be done, and if our data coverage is less than or equal to 50%, then how can we implement gen-based imputation for performance and maintenance. Step 3 is the physics informed estimation. I will use PINN architecture and mash up with LWR model. I will predict the level density and Q profile. Step 4 is the multi-object DRL. I will deploy a DQN and PPO agent, optimize a reward function. It will balance delay, Q length, and tailpipe emission. Step 5 is the explainable AI audit. I will use SAP-based layer to interpret the report for traffic engineering point of view. So I have 4 research objectives. Firstly, I will develop PINN, which will estimate the Q accurately using drone, then design a multi-objective deep reinforcement learning controller, which try to reduce delay and emission. In the 4th objective, that is RO3, we can see that it will evaluate framework, which is resilience for data based on data availability. Data availability can be vary from 50 to 100%. In the 4th, I will implement explainable AI toolkit so that I can visualize eco-mobility trade-off in the signal decision. So my research questions are, firstly, how do physical constraints improve Q estimation accuracy? Research question 2 is the finding optimal reward weighting to balance vehicle throughputs for fuel consumption reduction. Research question 3 is the how performance degrade under realistic sensor failure. Research question 4 is SAP-based explanation, how it can explain the traffic engineering principles regarding traffic signal control. So these are the 4 research questions. So probable publication can be resilience and PIN based Q estimation. Next objective is next paper, the P2 can be, it also can be Q1, and this paper will use multiple objective deep reinforcement learning for eco-friendly traffic signal. And lastly, it can be a Q2 paper, P3, that is it will use explainable AI and auditing trade-off. So if we look at the mapping of research objective, research question, and publication, we can see that the objective 1, that is research objective 1, is accuracy. Research question is RQ1 is physics versus baseline, and it will cover in the P1 public P1 paper 1. Similarly for paper 2 also cover research objective 3, that is resilience, and research question 3. Paper 2 will cover research question and research objective 2. Research question 2 is reward formulation, and Research objective 2 is optimization related information. In the publication 3, we can from the mapping we can see that that will be a Q2 paper. It will cover research objective 4 and research question 4, which are related with the explainability and explainable AI related information. Now let's deep dive into topic 2, which will use a hybrid physics informed learning model, and it will use generative imputation for robust traffic estimation for signalized intersection, and it will use sparse drone trajectories. So motivation of this the proposal 2 is drone-based traffic state estimation for signal at complex scenario of urban context like signalized intersection. So the research will address some critical problem like sparse and missing trajectory data in case of battery limits, environmental occlusion, and limited field view by the aerial drone. And the author will propose hybrid physics informed learning architecture, which merge generative adversarial network for data imputation, and it will also include traffic flow constraint. So I will reconstruct vehicle movement using statistical accuracy and physical plausibility considering, and also computational efficiency for real-time edge deployment will be included, and the project will provide a robust intelligent transport management using aerial surveillance. That's my motivation. If we look at the literature review, at first the Liu et al., which use physics-informed traffic state estimation and queue profiling, but it's not different from my paper. My paper will use sequential approaches and combine generative imputation with physics-informed estimation. So that will also improve my paper from the proposed review paper. I will include imputation, data, high fidelity trajectory data reconstruction, especially the trajectory reconstruction. Then in the paper 2, we can see that it will cover the hybrid fundamental diagram for urban traffic data imputation, also include macroscopic model they use and graph convoluted neural network use. The missingness is that it is used such as continuous occultation block, battery swap interval, and other type of data dropout are missing, are not included. This paper include macroscopic linking, but my study will use signal phase aware constraint to capture microscopic Q dissipation. In the third paper, Zhang et al., they reconstruct traffic state using generative adversarial network and time-space diagram. My study will improve purely data-driven gen by adding kinematic realism constraint, and it will so that it ensure vehicle follow traffic physics law. So little bit improvement with the existing review paper. And there are also 4 review paper, that is the fourth, not fourth actually, is fourth one. It use large scale PNUMA drone data set for multimodal environment, but I am including surveillance system and also data imputation. Next paper, that is Lee et al., is use comparative assessment of traffic data imputation, including prediction, interpretation. But I want to develop a generative adversarial network which use entire spatio-temporal context, forward and backward, and incorporate physics to capture stochastic accuracy. In the Zhu et al., 2024, they integrate network macroscopic fundamental diagram. They also include graph neural network, but Here in my paper, I will integrate signal timing for study traffic behavior and capture using graph neural network, and also include the uncertainty quantities using Bayesian PINN. The She et al. Use hybrid PIDL paradigm for traffic state estimation. It will use second order traffic models, and they also consider first order LWR and second order ARZ physics model. But my research will design for intersection addressing Q and discharge dynamics, and little bit different and have some solve some research gap of the Seattle paper. And these are the all 7 papers that is reviewed for the proposal 2. We can see all the review paper here. So what are the research novelty of my topic 2? Firstly, develop a physics signal phase aware constraint. I will develop the constraint for red or green phase to better capture Q dissipation. Then realistic missingness will be included, which will work as a benchmarking for drone video gaps, especially for contagious occultation block and spatial edge truncation. In the third, we can see that it unifies PINN and GEN architecture. It will combine generative adversarial network for generate physics plausible trajectory imputation. In the fourth, the uncertainty quantification, it integrates Bayesian PINN to provide confidence interval for traffic state estimation. It ensures risk-aware traffic management. If we look at the methodology concept, firstly, data layer, it will extract data from sky for trajectories, then use physics constraint generative adversarial network to fill trajectory gaps, consider the traffic kinematics and physics law traffic flow theories based on LWR, then estimate section layer in the third phase or third step. It use signal phase aware GNN graph neural network, consider the boundary condition, estimate traffic flow speed and density. Then in the fourth, it will optimize using tuning and quantization to enable or to calculate the real-time execution of edge device. So edge device or edge computing will be considered here. So the research objectives are, research objective 1 is to characterize drone-specific missingness pattern and impact on traffic state estimation. Research objective 2 is physics constraint using generative adversarial network and reconstruct missing trajectory. Research objective 3 is the hybrid physics-informed graph neural network architecture and integrate signal timing data to estimate accuracy. Research objective 4 is to develop a lightweight edge deployment version of the model for real-time management. Now comes the research question. I have 3 research questions. Firstly, how different drone video missingness pattern, what is this pattern and how it affects on estimation reliability. Research question 2 is the signal phase aware physics can improve accuracy of data-driven generative adversarial network or graph neural network models. Have to prove whether signal phase aware physics can improve the model or not. In the research question 3, it is on the trade-off between model complexity and computational speed for real-time edge deployment. It's regarding edge computing and edge deployment, and also consider the trade-off between model complexity and computational speed. I will deal with this stuff in this research question related work. Then the topic 2 will cover 3 paper 1 and 2 will be on Q1 and paper 3 will be on Q2. Paper 1 will use physics informed graph learning and it will use traffic state imputation. Paper 2 will generative data imputation covering physics constraint, and paper 3 is the lightweight physics informed neural network. It will use real-time traffic state estimation based on each device. And here is the map for research objective, research question, and publication. Research objective is the missingness impact, and it will cover the research question 1 and also will be discussed in the paper 1. Paper 2 will cover research question 2 and research objective 2 that will on data imputation and physics versus data driven study. Paper 1 and 2 combined, the core framework will cover signal error constraint and the traffic state estimation, which will cover by the research question 2 and research objective 3. If we look at the paper 3, that is on lightweight and edge focus, it will cover the complexity versus speed of the model in the as described in the model research question 3, and in the research objective 4, the edge deployment, which is connected directly with the paper 3. Now talk about the research topic 3, that is uncertainty aware explainability deep fusion framework. I will use high resolution trajectory reconstruction and estimate or predict the travel time using drone and probe data. So there is data fusion in this topic. So one of the motivation is multi-source data fusion framework and vehicle trajectory reconstruction, travel time prediction at urban signalized situation. Also sparse probe GPS data, which has wide spatial coverage and high resolution drone data will be mixed up together, not mixed, actually fused together. For this purpose, I will use Bayesian and graph attention network and align heterogeneous dataset, quantify uncertainties, and key objective involving positional error identification, minimum probe penetration rate. I will consider how much minimum probe penetration rate we need, and ultimately this work will provide a statistical validation of fusion technique for urban mobility and safety analysis and also emission estimation. So these are the literature review. Literature review is covered in the real-time traffic state estimation. It is also has some research gap which will be addressed by my paper. In the next paper, the Armand Tepari 2022 reconstruct lane level trajectories and smartphone GPS and loop detectors. By my paper will identify the address research gaps, focusing on urban signal intersection and moving beyond motorway only application. In the third, we can see that it works with the large scale urban traffic monitoring, but my paper bridge gaps between fusion of drone data with the probe vehicle data. Zhao et al. 2024 provide high precision trajectory data only, but validation deficit. I will validate my data and my model. That's my research gap addressing. In the Meheran et al., it reconstruct vehicle trajectory for urban arterial, but I incorporate stochasticity through uncertainty aware Bayesian learning. Kessler et al. 2022 use multi-sensor fusion such as loops, floating car data, Bluetooth for freeway. I will use graph attention neural network to handle spatial temporal mismatching and solve data qualities using learnable alignment mechanism. I will not use static weighing. Xi et al., which use the urban arterial trajectory reconstruction and extend it for intelligent driver model and particle filtering. But I want to propose the explainable AI using shape-based feature attribution to identify dominant error drivers. in signal phases and density. So these are the all 7 papers that will be reviewed, which are connected with the topic 3. And research novelty, if we look at the research novelty uh, of my topic 3, we can see that the firstly graph attention network is used for the trajectory completion. I use drone as a anchor. Then uncertainty aware Bayesian learning will be included, which will predict interval for trajectories and also estimate the travel times, reliability. And explainable AI will integrate, which will identify factors like state signal phase, which are most influence the travel time errors. Adaptive weighting, it will use learnable alignment mechanism, adjust weights based on real-time data qualities and penetration rate. So the research methodology concept include 4 steps. Firstly, data layer, which will extract trajectories from data from sky and align with sparse probe GPS point. Then fusion and reconstruction level, I use graph attention network, which act as an encoder and decoder to reconstruct the trajectory from drone and explainable prediction layer. In this layer, trajectory will fit into transformer or gradient boosting model, estimate the travel time and explained using explainable AI. Then validation and uncertainty layer, I will include Bayesian interference to provide confidence interval for our outputs. So the research objectives are, I develop deep fusion architecture using graph attention network to reconstruction vehicle trajectories and implement uncertainty aware model for travel time prediction. In the research objective 2, research objective 3, quantify the impact of varying probe penetration rate and predict the reliability of the travel time using the real world information. Research question 1 is the drone anchored fusion effectiveness for heterogeneous data. I will test to improve trajectory reconstruction over probe only method. Then research question 2 is the accuracy of travel time prediction, and research question 3 is the traffic features such as signal phase and density, how they influence on the prediction error, and I will assess using SAP contribution, SHAP contribution. So the research topic 3 will produce 3 publications. Firstly, focus on the deep fusion architecture for trajectory reconstruction, then use uncertainty aware and explainable method for travel time prediction, and paper 3 will cover sensitivity analysis regarding penetration rate and drone coverage. If we look at the mapping of research objective, research question, and publication, publication 1 will cover by research objective 1 and research question 1, which are trajectory reconstruction and alignment and focusing. Paper 2 is the explainable and uncertainty model, which cover travel time uncertainty of research objective 2 and research question 3, that is explainable AI and prediction of drivers. Paper 3, that is sensitivity analysis, which we will cover penetration sensitivity of research question 3 and penetration impact of research question 2. So these are the mapping. Now let's look at the topic 4, which is multimodal drone safety net. I will use a explainable graph-based deep learning framework. It will predict surrogate safety assessment considering heterogeneous vehicle dynamics. So let's first look at the motivation. My motivation is to develop a drone safety net, a framework which will transform traffic safety as a proactive system. It will use high resolution drone trajectory and graph neural network, predict potential vehicle conflict at signalized intersection, and it leverages deep learning and surrogate safety measures to forecast risk. And it it emphasizes on explainable AI, so the safety engineers can identify or predict the kinematic factors regarding driving conflict. Ultimately, this framework can provide early warning system, develop an early warning system so that intersection can be managed with better safety. So we have several literature review. Past literature review already use RNN, neural network, to predict future trajectories for intersection conflict identification. But I will move to the graph attention interaction model, which will treat vehicle as a node and capture complex non-linear spatiotemporal interaction. The second review paper use proactive safety diagnosis of separate central island, which use roundabouts using drone and measure surrogate safety measure. But in my proposed paper, I want to develop a reactive system where trajectory are forecasted 1 or 3 seconds ahead. In the third one, the Zheng et al. Introduced CitySim dataset, and they facilitate safety-oriented research using drone. However, in my paper, I explicitly address heterogeneity, incorporate multimodal class, say car, heavy vehicle, motorcycle into graph neural network node properties. In the 2023 Anisa et al., which enhanced conflict analysis using LiDAR and camera sensor fusion, but my proposed work will use also consider the circumvent ground level sensor limitation like occultation and multitask learning. It will simultaneously predict trajectory and conflict likelihood. It is more advanced than single measure diagnostic approach. The Vasco et al. 2023, which use vision-based investigation of traffic violation and human error. But my drone safety net incorporates explainable AI layer using SEP or attention map. The sixth one paper, we can see that it used microscopic driver crash risks during mandatory merging maneuver, and it will use the freeway interchange. In my framework, I will employ heterogeneous interaction layer in Gen and weighting interaction based on vehicle type and capture mode to mode risk profile. So little bit more advanced than the reviewed paper. There are also 3 other papers. The Lu et al. 2022 use deep unsupervised surrogate measure to identify the conflict at fixed threshold. But the proposed paper use multi-relational graphs where edge reflects specific mode interaction. The next one paper is use the safety assessment of Egyptian roundabout using PET, that is post-encroachment time conflict technique. My paper focused on the signalized intersection. Thus, roundabout gap is not addressed, obviously. The Wu et al., the 2020 use automated safety diagnosis using masked RCNN, recurrent convoluted neural network, and CSTR to extract trajectory. While this paper is retrospective diagnosis system, but my safety net proposed explainable graph-based framework for real-time forecasting, so little bit different and advanced than the proposed paper. So these are the all 9 reference paper I use for this topic 4, my proposed topic 4. If we look at the research novelty, which is the best part of this presentation, not presented this topic. Firstly, I will address the heterogeneous interaction layer, use multi-relational graph neural network GNN. It will assist different ways to interact based on vehicle types and they have different risk profile. Explainable AI will use to explain why conflict is predicted, is attributing risks, and kinetic feature will come up. Then graph attention interaction model will use beyond LSTM to GNN, which will treat vehicle as a node and interaction as an edge. Multitask learning will simultaneously predict trajectories, likelihood, and using a single deep learning architecture. Cross-site generation is a rigorous test for model transferability and training data set. It validates and independently collected drone data. So these are the four, so these are the not five, my nobility of this research topic 4. I have 6 steps for methodology. Firstly, data layer, which will extract trajectory data from sky, then retrospective SSM will be calculated from ground truth leveling, then multimodal graph construction for vehicle specific dynamic properties and edges will be identified. Predictive layer will construct a spatiotemporal graph for vehicle interaction, then apply graph neural network or transformer to forecast future trajectories for 1 to 3 seconds. Safety layer will derive predictive SSM for forecasted trajectories. Explainable AI layer will apply SAP to attribute risks to specify maneuvering and making system usable for safety engineers, and validation will use K-fold clustering, K-fold cost validation to compare with JNN performance against the baseline. I have 3 research objectives for this topic 4. Firstly, graph neural network will develop to incorporate multimodal vehicle classification, then their dynamic properties. Research objective 2 will evaluate impact of heterogeneous intersection on conflict risks, and research objective 3 will validate framework performance across diverse traffic mix. So what are the research question 1, 2, and 3? Firstly, research question 1 will include multimodal dynamic features, vehicle specific acceleration limit considering these criteria. Research question 2 will trajectory features prediction of conflict consistence considering different vehicle modes such as car and motorcycle. Research question 3 will model generalize for size and significant difference of traffic composition, how it can change the scenario such as high motorcycle volume or high truck volume, how can this composition has effect on the traffic stream or traffic dynamics, it will assess. So probable publication will be publication 1 and 2 are Q1 and 3 will be Q2. Q1, publication 1 is it talk about how the model generalized to size significantly different from the traffic composition, like high motorcycle volume and high truck volume in case what it happened. And publication 2 is the role of vehicle dynamics in predicting surrogate safety. And publication 3 will cover explainable risk attention for multimodal traffic conflict. It will consider signalized intersections. Here is the mapping of research objective, research question, and publication. Publication 1, that is methodology focus, will cover research objective 1, that is multimodal graph neural network, and research question 1 that will discuss on the impact of dynamics. Publication 3 will use explainable AI, and it will cover the research objective 2, that is heterogeneous interaction and feature consistency of research question 2. Publication 2 is on safety and validity focus. It will cover research objective 3, that is cross mix validation, and research question 3, that is generalizability. So these are the mapping of my topic 4. Thank you so much. That's all about my presentation for listening and watching my videos.